Okay, George, this is our layout. I think we finally have it here. So we have the 5 posts, and this is post number 1. This is post number 2 back here, post number 3, post number 4, and post number 5. And the way we have this laid out is, it's a little confusing, but all of the posts are facing in the same plane here. They're nothing to do with relating to the angle of the side of the slab. And if we take a look at what we've done here, you can see the center points that I'm going to talk about on the posts, and I'm going to send you a diagram. But basically, here's what happens. This center of the post is going to be right here, and we're 12 inches to the edge, and I think you were talking about coming out 18 inches with the overhang, which is going to be the purloins and also the rafter supports. So we do that across the front, the 18 inches from the center of the post, we're fine. And if we do the same overhang in the back, 18 inches past the center point, then we'll have a consistent front and back over here. So we're 18 inches to where Sal just pointed that out. And this is our marker from the house. We are 24 inches from the side of the house to the center of the post, as we've been speaking about. And I think the way we last left off is that was the notion that we were going to do an 18-inch overhang and leave 6 inches from the house, as Sal has it pointed out. We have a little bit of an issue here that we need to work through, because if we did the exact same thing over on the other side over here and we had the 18-inch overhang, we are into the setback zone for zoning purposes. So the overhang on the left side can only be 12 inches maximum. So I don't know if that means that we just make this side a 12-inch overhang, or and we leave that the 18, or we tidy it up and we make it 12 inches all the way around. So we can talk about that. And the angle that we have here, if we look at the angle, this angle was 66 degrees right there. That's the only angle that we have in the whole deck to give you the angle. And to give you an idea of what we're talking about, from center of post number 1 to center of post number 5, we have how many inches, Sal, on our map? 212 and 3/4 of an inch. Okay, so that's this from post 1 to post 5. And then we have from post 5 all the way to post 3, which is the rear post on the back. We have 274 inches. That's from post 5 to post 3, and that's center to center. Then if we take this post, it is centered between post 3 and post 5, and it's what, 11.5 feet? 11.5 feet between 5 and 4 and 4 and 3. And again, that's center to center. And then if we take the distance between the back 2 posts, 3 and 2, this measurement is 106 inches. That's center to center. And if we go from post 2 all the way to post 1, center to center, this was what, 21 feet even, I believe, from post 2 to post 1, 21 feet even. Okay. Then a few other important measurements, because this is the critical one. This is where the rafters are going to tie back into the house, George, right? So the distance from this center point of this column 1 to the house is 208 inches. That's from the center point of column 1 to that wall. And as you recall, that's where the 2 rafters, or 3, are going to actually probably tie in there. And we need to talk about how we're going to ledger it. Do we use your fiberglass piece of, rafter material to ledger it into, so we can talk about it? And that little return wall, to give you an exact measurement on here, I had it right on this piece of paper. Where is it on my diagram here? Oh, that's 68 inches. That return wall, Sal, just point that out. It's that wall right from here to here is 68 inches. And then from that corner to this wall right here, this was 133 inches wide. And to refresh your memory, George, the top from the finished cement slab to the top of the window is 10 feet. So if we have our whole system right, you need to make the column 10 feet high and then build the rafter support, the rafters, and the purloins on top of that. So I don't know how much more that brings it up, but it brings it up probably another 1.5 feet or something like that. And then this return wall here, this is the small return wall that goes from here to here. Where's my diagram? That's 134 inches long from where Sal is to this corner, and then that little return piece there, that's 52 inches long. And let's see, is there any other leg that makes any difference? Well, I'll give you what Sal's measuring now, which is one we missed. It's from the corner of the house to the center point of the post is how long, Sal?
66 and a half.
66 and a half. And then, so you have another measurement, even though the math should work out. Let's give George a measurement from this to the side of the house. I think we already did that, actually.
Yeah.
We did that as
76.
76 or 75?
Well, 75 over here in the corner.
Okay, let's call it 75 inches from the center line of 1 to 2, this line that we drew. There's 75 inches to the house. So I guess I'm giving that to you because that's going to dictate the length of the, what would that be, the rafters? Rafters that are going this way here, right? So I think that that gives us the distance. I know something else here that's missing, and I'm going to do this just so he has it. We gave George this leg, this width here. We gave him the top width. Why don't we just, for the fun of it, give him the measurement right from the center point of post number 4, right across. No, right, yeah, right about to here. Where are we?
Yeah.
How many inches you have? Oh, I'm sorry. Okay, sorry about this, George. We're kind of doing this real time a little bit.
Okay. 159 and a half.
159 and a half, and that's from the center of post 4 to the other line that goes across. Hopefully with the angle you don't need to figure this out, but I'm just figuring it out for you along the way here. Okay, so hopefully the geometry works out, and I think that's about all I can give you at this point. Okay, so this is Paul, Golden Gate Enterprises. This is the Oakley job, and I hope this all calculates out properly. Thank you. Bye.